name is Ahmad Hadri bin Mohammad Nordin, metric number AE170015, and for my presentation.
Hello, my name is Tatt, and my CE number is CE 107070.
Name is Aimi Nabila binti Mohammad Rosli. My metric card number CE 170017.
My name is Nur Syahirah binti Razali. My matrix number is CE 170108. In order to improve the throughput of the processors, pipeline technique is widely used to implement the instruction level parallelism. However, this technique also leads to data hazards, which has a great influence on the performance. Therefore, we propose a method called supply matching to detect and solve the data hazards efficiently. This project was conducted through a 5-stage microprocessor based on the PowerPC architecture with different approaches.
Okay, right now I'm going to present what we have come out from our finding using Quarter software. So as we can see here, all of these are the downloaded source code from GitHub that relate to our project about pipeline data hazard detection. At the beginning, we need to arrange the file in hierarchy here. So, what is hierarchy? An example of a hierarchy concept can be shown and can be understood from this figure. So, for example, Canada and Mexico both are located at North America. Same goes to Germany and Spain, where both of the country situated in Europe, which means North America cannot be exist without the presence of Canada and Mexico. Also for Europe, where Europe cannot exist if there are no Germany and Spain. Back to our program, it is just like a pyramid where the structure of program is built from bottom, which means we need to create the small program first, such as the register, adder, etc., before we proceed to the pipeline. So next is the entity. Entity is a thing with distinct and independent existence, or an entity can be defined as declaration of the existence and an establishment. So every single program, as I shown here, have their own entity. Entity can be set when we click here. So what happens if entity is not been set? The program will be undefined. In each of every program of hierarchy have their own entity. So now we are going to our main file. Here, okay, MIPS processor pipeline. So we can see here there are input clock, input reset, and 32 pin wire, and there is also the control unit, PC register, adder, shift, and gate multiplexer, and etc. So these are the main program that have been compressed. So from all of this program, which there are about approximately 26 program, we have successfully compiled without error 26 program file, where the balance of 2 file we got an error and unsuccessful. The unsuccessful program is the mux register and the MIPS processor TB. So here, mux register, set as top entity level first, and then we run. It will take some time. Okay, still waiting. Okay, so there is 4 error. Okay, if we see what the error are about, where it say there are 1029 input output pad in the design, where it is not fit in the pad location. So we have tried to remove the pin from looking guideline on YouTube and internet, but unfortunately we failed. And also we try to change the cyclone from 2 to 4, but unfortunately we also still cannot overcome the error and find the solution, and we managed to decide that the error was not from the coding but from the design. So next, moving into the part of the coding before, here where the main program. Therefore, from the main combination of the program, we can obtain and see the architecture of the program by selecting into RTL view. So from the RTL view, this is the architecture of the program. So we can see initially where at the beginning there is clock and port in P in, where 7 to 0, which means 8 bit. And also we can see at the output where P out is 31 to 0, which means 32 bit. So as I explained just now, before we forming the main product, which is the pipeline, here pipeline and here pipeline, so we need to construct first the hierarchy before that, which is for in this program, the shift left shifter and the adder. So as you can see here, the shift left is compiled at first before moving into the next to adder, where second compilation is done. So actually how the data move in from 16-bit to 32-bit can be shown through waveform, but we are unable to show because our program have error and cannot produce output. Hence, this is the waveform, but we fail to get the result, where we can see here the port in before is they have 7-bit, sorry, they have 8-bit, and the P out, which it have a 32-bit. So hence due to the error of the program design, the data hazard detection cannot be performed.
This is our conclusion in our project, which is first, the pipeline processor design is the main method of improving processor work efficiency. Next, design a 6-stage pipeline processor that divides the processor into 6 functional stages and balances each stage. The third one, the pipeline cannot avoid resulting into hazard, which it can prevent the next instruction where being executed during its designated in a clock cycle. The last one, we had solved a read after write data hazard by using forwarding as well as stalling methods so that the signal can be computed without error.
Our project is very complicated. Although we do not obtain the output result, but our group still managed to obtain the RTL architecture from the successfully running source code, because overall we have approximately 28 files and we only have 2 errors, and also we have learned on how to setting up the hierarchy and the entity for the program.
From the experiment that we had done, there are something we learned from it. First is better understanding in pipelining system and data hazards detection, theoretically. Next is, doing coding is not an easy task to do. We need to identify the error and try to correct it. In regards to this project, we can't really identify the error and we can't correct it. So, the data hazard pipeline cannot be simulated in this project. And lastly is, communication is very important in order to make this project works, especially when doing things in group.
The challenges that our group had faced during this project are the project board, which is the E2 board at UTHM. Since MCO start at 18 March, there will be no class at UTHM and we are unable to use the board to complete our project. Therefore, we have to change the title of our project due to this problem. Next, the challenges are we are unable to conduct troubleshooting. The coding of pipeline system are unable to be troubleshoot due to no model and board. Lastly, the system cannot be integrated. No board model and troubleshoot resulting in unable to integrate all systems.
It is important to prevent the pipeline process from getting into hazard, where the hazard can disturb the upcoming instruction while taking effect, which is not good for a pipeline processor. Thank you.